Bismillahirrahmanirrahim. Welcome to the Structural Engineering Software Application lecture number 11. In today's lecture, I will discuss introduction and analysis and design of 1D, 2D, 3D structure in ETABs. Okay, the lecture outlines contains the objective, introduction to ETABs and its key features and graphic user interface. Then example on analysis and design of multi-story building in ETABs. Then class task for student practice. Okay, lecture objective. By the end of this lecture, the student will be able to design and analyze multi-story building in ETABs. Okay, introduction to ETABs. It is an innovative and revolutionary ultimate integrated software package for the structural analysis and design of building. Incorporating 40 years of continuous research and development, the ETABs offer unmatched 3D object-based modeling and visualization tools. Fast, linear and non-linear analytical power, sophisticated and comprehensive design capability for wide range of materials, and insightful graphic display reports and schematic drawings that allow user to quickly and easily understand analysis and design results. ETABS key features: extensive modeling capabilities that include flexible grid system, and which is convenient in dividing and meshing of design objects, and multiple simultaneous rectangular cylindrical grid system are available, and accurate dimensioning with grid lines and snapping, right? And ETABs having capability to model different structure like frame, truss, wall, slab, foundation, and many other structures. And it contains a lot of automated templates for typical structures, and it has quick draw options to create object with one mouse click, and it has fast generation of model using the concept of similar stories, and it is very easy to edit, move, merge, mirror and replicate any kind of model. And ETABS has extensive analysis capabilities, includes linear static analysis, linear dynamic analysis, static and dynamic p-delta analysis, static non-linear analysis, dynamic non-linear analysis, push order analysis, multiple response spectrum analysis, multiple time history analysis, and construction sequence loading analysis. Okay, other capabilities include multiple views in 3D perspective with zooming and snapping option, on-screen assignment of properties, loading and support, powerful grouping, selection and display options, unlimited level of undo and redo, cut and paste geometry to and from spreadsheet, import and export of .dxf file for model geometry and from AutoCAD, detailed context sensitive online help, the analysis of integrated with post processing and design capabilities. And ETABS has powerful viewing option like this, having very sophisticated views are available for different model. And the parametric template includes the steel deck, the flat slab, the two-way slab, the waffle slab, rib slab, and there is also a built-in database of steel sections are available. And in ETABS, graphical section designer for defining custom section tool is also available, right? And there is multiple load pattern, load cases and different codes are available in ETABS. And then in ETABS, objective based modeling are there, where area object for wall, slab, deck, opening, spring, mass and load, and line object is available for column, beam, braces, links, springs, mass and loads, and point load object are available for support, spring, mass and load. Now graphic user interface of ETABS. When you open your ETABS, so this window will appear. The top most bar is actually called the title bar, like, and beneath the title bar there is a menu, we call it the main menu bar, and it is same just like SAP 2000, like. Below the main menu bar there is a main toolbar where different tools are available, that is actually obtained from the main menu. And main toolbar includes the save, undo and redo option, then some zooming option, right, then display options, and some other option are there that will be discussed one by one in upcoming lectures. Okay, then side toolbar, where different drawing selection and location tools are available. Then the model information, at this location the current model or the project information will be shown, and this is the modeling or the area, drawing area, where you will do your modeling, where you will model or draw your structure. And this is the coordinate system in ETABs, where x coordinate is along the direction shown, and this is the z direction, and this is y direction. And ETABs in grid lines, the spacing is also given like this, and it will give you the dimension value between the grids. And the bottom bar is called the status bar, where you can check x, y and z coordinate for a particular point, right, and where you can also check either you are working in story 1, 2 and 3. Similarly, it will display you, it will give you the height of your story, right, and there is a global and system is also there, right, and there is a unit option as well, where you can change your unit according to the requirement. Now, in order to add multiple window, you can use this option from this icon. So these three options will appear, where you can add new window, right, for separate work. Okay, example on analysis and design of 3D building system. Now I will discuss how to analyze and design this example in ETABs. Okay, the methodology followed is given in this slide, right, and the methodology is divided into three phases: phase 1, phase 2 and phase 3. And phase 1 is actually the pre-processing, where the different properties will be defined for a model. We'll create a new model, then define a grid system for that, right, then edit grid system if required for x, y and story data, then define materials, then define sections for beam, column and slab, then define load pattern, load cases and load combination, then meshing of shell element, then assign joint and loads. Okay, so with all these steps, and phase 2 is related to the analysis, where different load cases are set to run, right. In phase 3 is called post processing, where different results are displayed and to perform designing of structure. Okay, phase 1. In this phase, the following steps are involved. First of all, create a new model and grid system, and it can be accessed from file menu. Then second step is to edit grid system, and it can be accessed from edit menu. And then we'll define materials, define section, define load pattern, load combination and load cases, and it can be accessed from define menu. And step 8 is to draw element, and step 9 is to mesh your area element or shell element, then assign load and joints. Now let's discuss how to perform different steps. Okay, first step is to create a new model and grid system. For that, go to file and then click on new model. So model initialization option will open, where you can set your units and other preferences like display units, steel section database, steel design code and concrete design code, right. So initialization option are three, where you can set any option as per your requirement. If you use first option, it means that you save user defined setting, default setting. In second option, use setting from a model file, and in third option, you can set your own setting. Okay, once the model initialization option are set, then this window will open, right, and from here choose a grid only option, right, and in this option we can define the grid system along x, y direction, and also we can define the story dimensions. In our example, I will use uniform grid spacing and simple story data, right? In uniform grid spacing, number of grid line in x direction required are 5 and number of grid line in y direction required are 4, and the spacing between x direction grid line and y direction grid line are 5 and 4, right? Similarly, in the story dimension, I will use simple story data where number of stories required in the example are 6 and the story height in the typical story and bottom story is 3.2. Okay, here we can also specify a grid labeling option. So if you want to change the label of grid lines along x and y direction, so we can change it from this option. Also choose custom grid spacing and custom story data option. So for that kindly refer to next slide. In the custom grid spacing, we can enter a different grid spacing, right? So when you click on the custom grid spacing, so this window will appear. So in this window you can check, we can enter the different spacing between grid lines in the form of ordinates, right? Similarly, we can also enter a different grid spacing for y grid data, right? Okay, through this window we can define custom grid spacing, and we can also change a bubble size as required. Similarly, we can also customize story data. For that, just click on the story data, right? So this window will appear. In this window you can enter a different height of the stories, right? Okay, once the grid system are developed, so it will be look like this. Now, plan and elevation views. In ETABs, 3 options are available to display different views. One is the 3D, and the second is the plan, and third is the elevation. Okay, 3D view is simple, so I will just discuss plan and elevation view. Okay, plan view is actually in XY direction. You click on the plan, so this window will appear. From this window you can display the plan of any story, story 1, 2 and 3, 4, 5 and 6. Okay, elevation view will be either in YZ direction or XZ direction. When you click on the elevation, so this window will appear, right? Where you can define elevation of different grid lines. Okay, when you choose a grid line, so this elevation will be displayed, and it is actually YZ elevation. And in this elevation, grid line 1, 2, 3 and 4 will be displayed, and it is also given in this figure, right, where grid line 1, 2 and 3 and 4 are displayed along grid line A. Similarly, you can also display a grid line elevation along grid line 1, right? For grid line 1, this elevation plan will be displayed XZ elevation. In this elevation view, grid line A, B, C, D and E will be displayed for grid line 1. Now step 2, to edit grid system. For that, just go to edit, then click on the edit stories and grid system, or you just right click on your grid system and then choose add and modify grids. So this window will appear. From this window you can modify and show story data, and when you click on this option, so it will redirect to the window that is given in the slide number 19, right? Similarly, you can also add story, right? We can also define a new grid system. Okay, when you click on the new grid system, so this window will appear. If you want to create a local axis for any inclined load, we can also rotate the local axis along global X, Y and Z direction, just like we have discussed in SAP 2000, right? And then you can define number of grid line along X and Y direction, and then spacing of grid line along X and Y direction. And similarly, you can also modify and show grid system already defined. So when you click on this option, so it will again redirect to the window. Step 3 is to define materials, right? For that, go to define, then click on materials property, then add new materials. So this window will appear. In this window, define region material type, standard and grades, then click on OK. So this material property data form will open. In the general data form, you will enter the material name, material type, directional symmetry type, either isotropic and orthogonal, then enter material weight and mass, right? Then other mechanical properties including the modulus of elasticity, Poisson ratio, coefficient of thermal expansion if any, and shear modulus. Okay, step 4, where I will define section property, frame section, and in frame section I will define beam and for that go to define menu, then section property, then click on the frame section, then add new frame. This window will appear. From this window I can choose different cross sections, but in example I will choose the rectangular one. This window will appear where I can define the section dimension, depth and width, and some other properties. Okay, so first of all I will define beam. The depth for and the width for the beam is 450 mm and 300 mm. Okay, in order to differentiate between the beam and column design, so I will change the reinforcement, right? So for that I will click on the modify and show rebar. So this window will appear where I will change the design type from column to beam. Similarly, in case of the column design, I will choose the first option, right, for the column. So this window will appear. Okay, in both reinforcement data form for beam and column, the rebar materials for longitudinal and confinement bar is selected. In case of beam reinforcement data form, top and bottom bars covered is selected, right? Similarly, in case of column, the reinforcement configuration is selected, then confinement bars, right? Similarly, the longitudinal bar cover and the number of longitudinal bar along 3 direction and 2 direction is selected, and along with the number of bar, the longitudinal bar size and area is also selected in this data. And similarly for the confinement bar in case of column design. Okay, for further detail about these two reinforcement data form, you can refer to the previous lectures. Okay, once the frame section is defined, next to define slab section. For that, go to define section property, slab section, and add new slab section. This window will appear where I will define the name of this section, then the slab materials, right? Then modeling type. So actually there is different modeling type available. So I will choose the shell thin. Okay. Then I will choose the property type slab, right? Then I will enter the thickness of slab, that is 120 mm. Step 5 is to define a load pattern where I will define dead and live load, right? For that, go to define, then click on the load pattern. This window will appear where I will enter dead and live load pattern, right? So for dead load, the self weight multiplier is equal to 1, and for live load, the self weight multiplier is equal to 0. Okay, step 6 is to define load cases. Okay, for that go to define, then load cases, then add new. This window will appear where you can define different load cases, right? ETABs create by default load cases for live and dead. So if you want to create a multiple or a combination of dead and live load, so you can add a new load case in this window. Okay, step 7 is to define load combination where 1.2 dead load plus 1.6 live load combination will be defined. For that, go to define, then click on the load combination, then add new combination. So this window will appear where I will enter a dead and live load having scale factor of 1.2 and 1.6. Now step 8, where I will draw different members or section including beam, column and slab. For that, go to draw menu, or you can also choose a different option from side toolbar, and then click on the draw beam, column and brace for beam and column section, and for slab section I will choose floor or wall. Okay, in order to save time, I can draw a first story element and replicate it to the upper stories. Okay, for drawing beam and column, the following different options are available that can be used as per the requirement. Okay, in our case I will choose the quick draw beam column option to draw different beam and column at different location. Similarly, for floor and wall drawing, the following different options are available, and that option can be used as per the requirement. So I will just use the quick draw option, where I will choose the slab, right, and then I will draw the slab at particular location. The area element and all other frame element is drawn. Then next step is to mesh the area elements. So for select all the slabs, then go to edit, then click on the edit shell, then click on the divide shell. So this window will appear. So from here I will divide the slab into 10 by 10 areas, right? So then I will click on OK. So the slab will be divided, shown in figure. Okay, next step is to assign joints. So all the joint in the example is fixed. So for that, go to select all joints, then go to assign, then click on joints, then restraints. So this window will appear. From here I will choose the fixed one and then click OK. So the fixed support will be assigned at particular joint. Okay, step 11 is to assign loads. So in example I will assign frame load. So for that I will select all the beams. Okay, so for that I will go to select, then click on the property, then frame section, and then click on the beams. So all beams will be selected, and then I will assign load. For that I will go to the assign, then click on the frame load, and this window will appear. Apply the dead load, right, and I will choose the forces, right. I will apply a uniform dead load of 1 kilonewton per meter, right. Similarly I will apply a live load. So for that I will change the load pattern name dead to live, and then I will assign 3 kilonewton per meter load, and the direction of load will be toward gravity. Similarly we can assign any kind of trapezoidal load from this window as well, and also we can apply moments. Okay, trapezoidal load and moments I have already discussed in the previous lecture, so kindly go through the previous lecture. Okay, once the then I can replicate the first story elements to the upper stories. For that I will select all the elements included in first story, and then I will go to the edit menu, then choose the replicate command. So this window will appear. So first option is the linear, where I can replicate the different element along x and y direction and number of time. Similarly I can also replicate the element at particular 2 points on the model which I choose from this option, right. In order to replicate along z direction, so for that I will select story, right. When I choose the story option, so I can select all the story where I want to replicate the particular elements, right. So in our case I will select all the story till story 2, and then click on OK. So the first story element will be replicated up to story 5. Okay, this is the final model of the example. Okay, phase 2 is to perform analysis, right. For that just click on F5 or just go to analyze menu, then set load cases to run. So this window will appear, right. So from here you can check either you want to run a particular case or not, then click on the run now. Okay, once the analysis is completed, next phase is to display different result, that where different result will be displayed. For that go to the display option, where I can display a deform shape, or I can also show forces and stresses. Okay, I can also access the different display option from the standard toolbar, and this is the icon for show forces and stresses in members, and this is the icon for show forces and stresses in the shell element. Okay, for frame element this window will appear. From this window you can display moment 33, shear force 22 for particular load case and combination. And in case of shell forces and stresses, you can also display different result like resultant forces, stresses. Then in case of resultant forces you can display the maximum forces, the maximum bending moment, and the maximum shear force, and you can display the bending moment along different direction and shear force along different direction. Okay, in the figure different results are shown. Okay, the first diagram shows the displacement result, and the second shows the reactions of the joints, right, and the third diagram shows the moment 33, right, in the different frame elements, and 4 diagram shows the maximum bending moment diagram for shell element. Okay, you can also display a story response plot. For that, go to display option, then click on the story response plot. So this diagram will appear and it will show the displacement at x direction and story at y direction. So it will actually give you the drift of story uh, along global x direction and along global y direction. Okay, now next step is to perform designing. Okay, for that go to a design menu. So this window will appear where I can choose the type of design as per the material, right? In our case, the material is concrete, so I will choose the concrete frame design. When I click on the concrete frame design, so further option will appear, so where I can view and revise preference, the rebar selection rules for the column, rebar selection rule for the beams, right? Similarly, I can select design groups and I can also choose a design combination. Once all the above steps are completed, then I will just start design and check. Okay, once the design is completed, then I can display different design information. I will go to concrete design, then click on the display design information. So this window will appear. This window will give me the information of the reinforcement at top and bottom direction as well as the shear steel. Okay, for complete design, just click on the details option, so complete design will appear. Similarly, I can also display some other design information like longitudinal reinforcing, rebar percentages, shear reinforcing. Similarly, the PM interaction diagram for columns. Okay, when I choose longitudinal reinforcing, so this will give me the longitudinal reinforcement. By using the area reinforcement, I can choose the number of rebar as per the requirement and size of reinforcement. Also, I can display rebar percentages, so it will give me rebar percentages, either it is within limit or not. Okay, example on analysis and design of 3D building system. Okay, now I will solve the example given in this slide step by step in ETAB. And it is a multi-story frame structure where beam and column size is 300 by 450 mm, right? And the slab thickness is 120 mm. And the beam length along x and y direction is 5 meter and 4 meter respectively. And the story height is 3.2 meter, right? So the column length is 3.2 meter, right? And it is subjected to a live load of 3 kilonewton per meter square and floor finish load, or it is actually the dead load, which is 1 kilonewton per meter. Okay, a grid system for this example, actually 5 grid line required in x direction and 4 grid line required in the y direction, and there it is actually 5-story building including base, so total 6 story will be required along z direction. Okay, now let's see how to analyze and design this structure in ETABs. Okay, first of all, create a new model. For that, go to file, then new model, then set model initialization, where you will set different preferences like display units, steel section database, steel design code and concrete design code. And initialization have 3 options. First option is use save user default setting. Then second option is use setting from a model, and third option is use built-in setting with. So I will use this use built-in section with option, where I will set display unit, because in an example the unit are in metric SI unit, right? Then click on OK. This window will appear where I will choose a grid only, right? In this window, grid system is divided into 2 options. One is grid dimension in plane along x and y direction, and the second option is related to the story dimensions, right, where story is added along z direction, right? In our example, I will use the uniform grid spacing and simple story data, because the spacing between grid lines are equal, and similarly the story height are also same. So in our example, 4 grid line required in x direction and 4 grid line required in the y direction, right? And the spacing between the x direction grid line are 5, and along y direction the spacing is 4. Similarly, for story dimension I will use simple story data, where I required 6 story including the base, right, and the typical story height is 3.2 and the bottom story height is again 3.2. Then click on OK. Now the grid line are developed along x, y and z direction as per the example. Next step is to define materials. So for that, go to define, then click on the materials, then add new material, right. I want to define the concrete material, so choose the concrete, right, then keep the standard and grid as by default, then click on OK, right. Change the material name, let's suppose it's concrete, and then specify the weight density or specify the mass density, then specify the other mechanical property like the modulus of elasticity, the Poisson ratio, the coefficient of thermal expansion, the shear modulus. I will keep all the values as by default, right, so you can enter all the different values in this data form to define your materials. Then click on OK, then OK. Okay, next step is to define the cross section. First I will define the frame section, beam and column. Okay, then add a new property. Okay, so I will going to define the concrete rectangular section for the beam. Okay, then change the name to the beam, right, and the depth of the beam is 450 mm and width is 300 mm, right. Okay, in the reinforcement we have to modify and show the rebar, because we are defining it is a beam, so we will change the design type from column to the beam, then click on OK, then OK. Then I will add copy of this beam, because the dimension of column is same. I will just change the reinforcement type, then add copy of this property and change the name to the column, and the dimension are same. I will just change the show rebar option to the column, then click on OK, then click on OK. Okay, now next step is to define a slab section, that is the area section. For that, go to define section property, then slab section, right, then add new property, and I will give it name slab, and I will choose the material type that I have defined previously. Okay, the modeling type is shell thin, so I will choose shell thin, and it is slab, so I will choose slab, and the thickness of the slab is 120 mm. So click on OK, click on OK. Next step is to define load pattern. For that, go to define, then load pattern. Okay, in ETABs dead and live load pattern is already there, is by default, so click on OK. Okay, next step is to define load cases. For that, click on define, then go to load cases, and then we can add new load case. For example, the name of this case is case, right. We will enter, we will add dead and then live. Okay, so this load case is defined. Okay, next step is to define a load combination. For that, go to define, then load combination. So in our example, if I want to add 1.2 dead load plus 1.6 live load, then add new load combo. Similarly, we can also add default design load combination that is available in the code, right. Then go to for the new load combination, then go to add new combination, click on the add new combination, then change the name of combination from 1.2 dead load plus 1.6 live load, then enter 1.2 dead load, then enter 1.6 live load. Okay, the load combination is defined. Now next step is to draw frame elements, then draw slab element. First of all, I will draw a beam. So for that, I will change the plan to story 1, because the beams are at story 1, right. Then I will choose quick draw beam option, frame option. Then I will choose a beam from here because I have to draw the beam. Then I will select this plan, and beam will be drawn at first story level. Okay, next step is to draw a column section. So for that I will choose any elevation, right, and I will draw a column at base level. So again choose this option and select column from here, then draw column. Okay, all 4 columns are drawn. Now I can replicate these 4 columns along x direction. Select all the column, right, then go to edit, then select a replicate command. Okay, it is actually the linear replication. So I will replicate along x direction. So what is the distance along x direction? It is actually 5 meter. And how many times I want to replicate? 1, 2, 3, 4. 4 times I will replicate the column. Okay, so the column is replicated up to 5 number. Now I will draw a slab. So for that I will change the view to plan, and I will go to story 1. Okay, now I will draw this slab, and I will choose slab section, and then I will draw at particular location, right. Now next step is to assign joints. I will assign joints, and I will move to the bottom portion, and then I will select all joints, and then go to assign, then joints, restraint. Okay, the supports are fixed, so I will choose fix and click on OK. So the support are assigned. Okay, next step is to assign dead load and live load to the beams. So for that I will select all the beams. So go to select, then properties, then frame section, and I will choose beam for selection. So all beams are selected. So now I will apply 1 kilonewton per meter square dead load and 1.5 kilonewton per meter square live load. For that go to assign, then frame load, then distributed load. So first of all I will enter dead load, right. So enter 1 kilonewton per meter uniform dead load, right, and in the gravity direction. So click on OK. Then again select the beam for live load, and then go to assign, frame load, distributed, and change dead to live, and enter 1.5 dead load. Click on OK. Okay, now first story is completed in all respect. Now we are in position to replicate the first story. Okay, for that select all the members in the first story, select column and beam, right. Then I will select slab, then choose slab. Okay, and now I will replicate this all members to the upper story. For that go to edit, then replicate command. Okay, I want to replicate a long story, so choose the story option, right, and I want to replicate in all 6 stories, so choose select all the 6 stories, then click on OK. So the first story will be replicated up to 6 stories. Okay, if you want to display load, for that you can go to display option and load assignment. So from here you can show your load assignment on joints, frame and shell, right. So the load is shown. Now model is ready for analysis. For the analysis, go to analyze and set load cases to run, and then click on run now, and I will save this example. Analysis completed. Okay, if you want to display multiple windows, for that you can add another window by this option, add new window, right? Similarly over here we can also add new window, and you want to remove the extra window, so just select this option, right? Okay, now we will display different results. So to display for frame element, so go to display and then click on the show forces and stresses. For the frames, you can choose frames, and I want to display moment 33 along with values. Okay, so the moment 33 value will be displayed, right? Similarly, if you want to display shear force diagram, for that you can also access result from here, right, and choose shear to 2. Okay, similarly, if you want to display a joint reaction, so for that use this icon. And if you want to display all three components, fx, fy, mx, my and mz, so it will display all different reaction along x, y and z forces and moments. If you want to display the result shell element, so choose this icon. Okay, we can display resultant forces, shell stresses and shell strength. For resultant forces, for example, I want to display a maximum value, so click on OK and go to plan view to check result for shell element. So this is a result for shell element, and it is the maximum bending moment diagram for slabs, right? Okay, once the analysis is completed, now we can run design for this building. So for this, go to design. Okay, so it is a concrete frame design, so choose concrete frame design, and we can select design combination under which we want to design this particular structure. So it is the combination is 1.2 dead plus 1.6 live, so add it to design combination, then click on OK. Then we can run concrete frame design, right? Start design and check. Okay, so the design is completed, so it will give you the longitudinal reinforcement, right? We will change to the elevation, so this will give you the reinforcement at bottom, at top level in the millimeter square, right? Similarly, if you want to display the other design result, for that go to design, frame design, then display design option, right? If you want to display rebar percentages, you can also check the rebar percentages, beams, column and slab are passed or not. Okay, for that go to design, concrete frame design, then verify all member passed. So it give you all concrete frame passed the design check, so the member cross section and the slab cross section is okay under the applied loads. Okay, this is all about analysis and design of multi-story building in ETABs. Now task for the student practice. In task 1, analyze and design 3D structure given below, right? In task 2, analyze the given beam under the application of different kind of loads, and also analyze this kind of frame, right, in ETABs. Thank you so much. This is all about lecture number 11.